Okay, so this is AP Calc BC, and then these are the free response from 2008. All right, I'm gonna actually work backwards because the last two problems is material that is just essentially only for you guys. All right, it's not covered by the AB exam, so we're gonna just start with those. And we will skip the polar question because that is not covered on your exam. All right, so I thought I'd start with the series question because I think there's a good chance you guys will get a series question. All right, the Maclaurin series for ln of 1 plus x is given by this. Cool. On its interval of convergence, the series converges to the function. And now we have a function, we're defining a function as this composition. All right, and then we want to know what are the first four non-zero terms. Okay, so how do I go about doing that? Anybody want to help me out? Divide by 3 and multiply by x. Okay, so I like that. That is much better than trying to find all the derivatives. All right, so we can just do a function transformation here, and we can take our first four terms, and we can multiply by x because the function's multiplied by x, and then we can divide by 3 because the function with the x, the argument, is divided by 3. So we can just take x over 3, and then we're going to multiply through your first four terms. All right, so we should get x squared over 3 and x to the third over 2 times 3 squared. All right, is everybody with me on the 3 squared here? So it should be 3 to the n. All right, because this is the argument, right? Everybody okay with that? So I got x to the fourth over 3 times 3 cubed minus x to the fifth over 4 times 3 to the fourth. All right, and the reason for this is this x becomes x over 3 squared. All right, this one becomes x over 3 cubed. Okay, so those are our first four non-zero terms. And then what did we do to our general term? Well, all we did was we kept our alternating series, so -1 to the n plus 1. And then we have x, we added 1, so we have n plus 1. And then we keep our n, so we're still dividing, but now we have a 3 to the n term. Does anyone have any questions? Yes, no in the chat box. Okay, determine the interval of convergence and show your work. Okay, so how do we go about showing the interval of convergence? I'm going to minimize to give myself some more room. Okay, so we have a couple of ways that we can do this. All right, and I'll show you both ways. So the easy way is to take, well, I don't know if it's the easy way. All right, one way is to take the limit as n approaches infinity of your general term, So I'll just say an plus 1 divided by an. All right, and then kind of do the work from there. The second one is to manipulate the function that we have. All right, so I'm going to do it both ways. So I'm going to take the limit as n approaches infinity, and then we want to take your general term, and then you want to do it plus 1, so the term plus 1. All right, so negative 1 to the n plus 2, so I'm just adding 1 to my exponents. All right, x to the n plus 2 divided by n plus 1, and then 3 to the n plus 1. So essentially what I did here was for every time I saw an n, I replaced it with an n plus 1. All right, and then I'm going to take the ratio of that to the term that I already have. So negative 1 to the n plus 1, x to the n plus 1 over n times 3 to the n. All right, I put this in absolute values, and then we start to simplify. All right, and then the way we would simplify this, I'm going to keep change flip on the division. So limit as n goes to infinity. All right, change the division to multiplication and then flip your fraction. Okay. All right, and then now we're going to start canceling things. So the 3 to the n will cancel the exponent there, and I'll just get a 3. All right, the negative 1 to the n plus 1 will cancel, and I'll just get a negative 1. The x to the n plus 1 will cancel, and I'll just get an x. And I think that's about all I can do. So I should get limit as n approaches infinity of negative x over 3, and then I've got the n terms that I can't cancel. All right, n over n plus 1. All right, as n goes to infinity, this term goes to 1. And so I'm left with absolute value of x over 3. I can drop the negative because I'm in absolute values. All right, and then our interval of convergence is going to be when this thing is less than 1. So x over 3 is less than 1. And if I just multiply through by the 3, I get absolute value of x is less than 3. All right, and that's our interval of convergence. So then our radius of convergence is just half of the length of that, which is 3. All right, so essentially that's it. All right, does anybody have any questions on that approach? All right, I'm going to show you the other approach. I'll do it up here. Okay, the other approach is to say that your interval of convergence for ln of 1 plus x is 1. All right, and so then for our series, this one, all right, this is going to converge absolutely when that argument is less than 1. Okay, so then we're in the same spot here. This gets you to absolute value of x is less than 3, so then your radius of convergence is then 3. All right, and then we would have to check the endpoints here. All right, and so we would have to do this in either case. And so we'll go ahead and do that. Is everybody with me? Okay, great. So I don't want to erase that. Okay, so let's go ahead and check the endpoints. All right, so let's let x equal negative 3. We'll check the left endpoint. All right, then our series becomes the sum from 1 to infinity of negative 1 to the n plus 1, and then I'm going to just plug in that x. All right, so I get negative 3 to the n plus 1 divided by n times 3 to the n. All right, and then if I simplify, I get n equals 1 to infinity of 3 over n. All right, and then we know that this thing is going to diverge by comparison to 1 over n. All right. Okay, and then if we're going to do the other endpoint, we want to let x equal 3. So sum of my terms from 1 to infinity of negative 1 to the n plus 1, and now I'm just going to plug in my x is equal to 3. So I get 3 to the n plus 1 divided by n times 3 to the n. All right, and then now I don't get to cancel that negative 1 to the n plus 1 and roll it in here. Everybody okay with this? Essentially what I did was I said that this is negative 1 times negative 3 to the n plus 1, which is 3 to the n plus 1. I don't get to necessarily play with that here. All right, this gives me negative 1 to the n plus 1 times 3 over n. Okay, now this looks real similar to that, but this term here makes it very, very different. All right, because this is decreasing and alternating, this is going to converge by the alternating series test. Okay, so then my full interval of convergence, that left endpoint is open because I diverged there. And the right endpoint is closed. Okay, does anybody have any questions on how we got there? Okay, so then in terms of what the AP wanted to see, if you set up the ratio, you got a point for setting up the ratio. You got a point for computing the limit. You got a point for getting the radius. And then you got a point for just looking at the endpoints. So even if you just stated that you have to look at the endpoints, you would have gotten that point. And then you get a point for actually getting the right answer. Okay. All right, so let P4 of x be the fourth degree Taylor polynomial for f around x is equal to 0, and we're going to use the alternating series error bound to find an upper bound. Okay, so the concept here is that your P4 of 2 minus f of 2, sorry guys, the kitten decided to run across the laptop. All right, this, the error bound here is the magnitude of the next term in the alternating series. All right, so essentially what we're going to do is evaluate this for 5. Okay, so what we get should be 2 to the 5th. All right, and I'm using this one here. So 2 to the 5th over 4 times 3 to the 4th. All right, and that term should be negative, but the magnitude is going to take care of that negative. All right, and if we plug that into a calculator, I should get 2 to the third over 3 to the fourth. All right, just canceling this out. And that would give me 8 out of 81. So your series is bounded by less than 8 out of 81. All right, does anyone have any questions? No? Yes, no, maybe? Which series was used again? So, given that they called F this, I used F. So I use this term. That's a good question. No problem. Okay, so we can skip question number 5 because polars and parametrics are not on your exam. And we'll go to question number 4. Okay. So let me see if I can unerase. Hang on. I don't think I can unerase, but let me put the problem back up and try to answer your question. So all of the calculations that we did here were based on, yeah, no problem. So all of the calculations for A, B, and C were done based on the function. All right, and then we just used the series that they gave us as something that we can manipulate. All right, does that make sense? So when we got the -1 to the n plus 1, x to the n plus 1 over n times 3 to the n, this was used for the entire problem. All right, so both of those were based on this, not this. Does that make sense? Yes. So in part A, we derived this from this. So essentially what we did was we took x and we changed the x to x over 3, and then we plugged it in here. All right, and then we multiplied by x. That's how you transform this function into that. Let me show you the first couple of terms so you can see. So we plugged in the x, so x over 3, and then we multiplied by x, so you get squared. All right, minus, and then I'm plugging in x over 3 for x squared. So I get x over 3 squared times another x, but I have the 2 that I'm dividing by. So this became x to the third over 2 times 3 squared. All right, and then the next term, all right, I have the 1/3 that was there, and I have x over 3 cubed, and then I'm multiplying by x. The original function just helped you get the series for this function, yes. That's all that it was there for. Okay. And then to answer the question that was sent privately, the question was, what's covered on this year's AP? And essentially everything except for parametrics and polar. So everything you were responsible for before minus parametrics and polar. Okay, so the height of a tree at time t is given by this twice differentiable function where h of t is measured in meters and t is measured in years, and then we have some values. And then we want to estimate h prime of 6. So how do I go about doing that? So we can use the data, set up a slope. Great. So we're going to do h of 7 minus h of 5 over 7 minus 5. All right, and I chose 7 and 5 because 6 is right smack in the middle. Okay, so we get 11 minus 6 over 2, which is 5/2. All right, and we want to make sure we put in the units. So this would be meters per year. All right, that's that. And then if we wanted to interpret that, that's the rate at which the height of the tree is changing in meters per year. Any questions on part A? Great. Okay. Explain why there must be at least one time t where the slope is equal to 2. Okay, so this is starting to look like something that might reminisce of the mean value theorem. So remember that for the mean value theorem, what you need is your function to be differentiable on whatever your interval is, and then be continuous on your interval. All right, and then it would say that there exists a value c such that h prime of c would be equal to 2. All right, and we're charged with finding that. So I'm just going to call your attention to like what drew my eye. So we're looking for, h of b minus h of a over b minus a, and I want this to equal 2. All right, so I'm kind of looking at the 6 and 2 over the 2-step interval. All right, and so if I look at h of 5 minus h of 3 over 6 minus 2, over 5 minus 3. All right, I get 6 minus 2 over 5 minus 3, which is 4 over 2, which is 2. All right, and so this works because of the mean value theorem. And we know that the height of a tree is going to be continuous over the lifespan of the tree. All right, and so that was all that you needed to do. You need to set up a ratio, and you needed to interpret it using the mean value theorem. Does anyone have any questions on B? So given that you guys have your, would we have to say we're using the mean value theorem? Yes, you do. So given that you guys have your exam open notes, I would consider writing out the major theorems and, having the hypotheses readily available. So the hypotheses of the mean value theorem are continuous over the interval and differentiable on the interval. So you need to state that when you're doing these types of questions. So since you get, you get to have your notes, and that's not cheating. You should write down the major theorems and the hypotheses. Which theorems would you recommend that we write down? So I would maybe write down the intermediate value theorem, the mean value theorem. I think there's an extreme value theorem. Rolle's theorem goes along with the mean value theorem. I can compile a list for next time. Okay. Okay, use a trapezoidal sum with 4 intervals to approximate the height of the tree. Okay. All right, so so let's remember what the average value is. So the average value is 1 over b minus a, the integral from a to b of h of t dt. All right, and so we are figuring out for 2 to 10. So we need to approximate 1 over 10 minus 2, the integral from 2 to 10 of our function. All right, and we're going to do that using the use a trapezoidal sum rule, all right, like they asked us to do. So this is going to be 1/8, and then we're going to set up 4 sums. All right, and so if everybody doesn't remember the area of a trapezoid, I guess it's not a parallelogram, but I'll just say area of a trapezoid. All right, this is base 1 plus base 2 divided by 2, so you average the bases times the height. All right, and so in our case, the height here is going to be the, like, your T1 minus, or T2 minus T1. All right, and our basis is going to be, h of T2 and then h of T1. All right, and so I'm just going to go through and kind of find all of that. So 2 plus 1.5 divided by 2, so that's the height. And then the distance is 1 for that one. All right, and then we go to the next one. So 2 plus 6 over 2, so these guys, and then the difference there is 2. And then 11 and 6 divided by 2, the distance here is 2. And then the last one is 15 and 11 over 2, and they're 3 apart. Okay, and if we chug this all together, we get this. Okay, and so then remember for this year's AP and then all APs in general, that it's perfectly okay to leave it unsimplified. Right? They're not going to take points off if you don't simplify it. You can leave it like that. Right? They're assuming you do not have a calculator or that you don't necessarily need one. All right, does anyone have any questions on part C? Great. Okay, so the height of a tree can be modeled by this function. When the tree is 50 meters tall, the diameter of the base is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height with respect to time when the tree is 50 meters tall. All right, so this looks like a related rate, and not as easy as when you were in AB, but we have to actually solve for x here so that we know what to plug in. So if I go ahead and do that, so I'm going to set 50 equal to 100x over 1 plus x. All right, and you can kind of see that x is going to end up equaling 1, but I'll go ahead and do the algebra. All right, so this is when x is equal to 1. All right, so from there, we can go ahead and do the related rate. All right, so for the related rate, I'm going to take the derivative with respect to time of g of x. All right, and so then let's remember that that is your d dx of g of x times dx dt, and then you can kind of see that that becomes d dt. All right, and so I'm going to go ahead and take the derivative of that function. So we're going to use the quotient rule and the chain rule. So 1 plus x, derivative of the top is 100, minus 100x times the derivative of the bottom, which is 1. And then all of that over 1 plus x squared. And then we can't forget the dx dt. All right, and so that was given to us. All right, so I'm going to go ahead and simplify. When I distribute that 100, I get a negative 100x. So this equals 100 over 1 plus x squared times dx dt. And then we can go ahead and just plug in our numbers. All right, so 100 divided by 2 squared times the 0.03, which gives me 3 over 4. And then we want to make sure that we have the right units. So this is meters per year. Okay, does anybody have any questions? Okay, everything clear? All right. So we'll go to question 3, which is going to be our last question. And then we can discuss what you guys want to do next week. I have a good idea, but we can discuss. All right, so here's our last problem. All right, graphical interpretation. Okay, so we have a graph of a continuous function g, the derivative of f. So I personally would make a note that this is a derivative. Okay, the function g is piecewise linear, and then they give us a function for 3 to 6. Okay, and so pretty standard problem like we've done the past week, 2 weeks. All right, we want to know what is f of 5, all right, and we were given an initial value. So we have to start at our initial value and then use that to go backwards to find the area, okay? So our f of negative 5, you always start with where you are. So f of 1 plus the area from 1 to negative 5 of g of x, okay? And then I'm going to flip this around so that the bounds make some physical sense. All right, this becomes negative 5 to 1 of g of x. All right, so when you flip the bounds, you change the sign. Okay, so then we can go ahead and get the area of this region, and I'm going to go ahead and break it up into a, I guess, a rectangle and then a triangle. All right, so from negative 5 to negative 2, that's the rectangle. So that area is, let's see. So it looks like the height is negative 3 and the base is going to be 4. Is that right? No. 1, 2, 3, 3. So that's negative 9. All right, and then the other part is 1/2 of base times height for the negative 2 to negative 1. So 1/2 of 1 times 3, which is 3/2. I have no area here, and then I need to get the triangle from 0 to 1. So 1/2 base times height again. So 1/2 of 1 times 2, which is 1. All right, and so that is the area that is enclosed, and this should be negative. All right, so that's the area enclosed here. So then I can just start with my initial value, 3 minus, and then if I add these up, I get a negative 19 over 2, which is 25/2. All right, and so again, you could have left it unsimplified, and if you wanted to leave it as negative 3 minus negative 9 minus 3 over 2 plus 1, that's also perfectly fine. Okay, any questions? So all of that was perfectly fine. Okay, great. Everyone doing okay? Okay, fantastic. You guys just need to get warmed up. Okay. Okay, so for B, we want to find the integral of this thing. And since we know a value here, so I think it's good to break it up from 1 to 3 and then from 3 to 6. All right, so probably a good idea. So I'm going to set it up as the integral of from 1 to 6 of g of x is going to be the integral from 1 to 3 of g of x. All right, plus 3 to 6. All right, and then why did I choose to do that? Because these are two different functions. All right, one is, I think, fairly easy, and then the other we have a function, so we can go ahead and deal with that. All right, so two different functions, two different integrals. So integral from 1 to 3 of 2 dx plus the integral from 3 to 6 of the function that they gave us. Okay, so 2x from 1 to 3. And then when I integrate this thing, I can do 2/3 x minus 4 cubed. All right, from 3 to 6. All right, this becomes 6 minus 2, which is 4. And then 2/3, plug in the 6, you get 2 to the 3rd. And then I'm going to subtract 2/3 of, so I get a negative 1 cubed. Okay, so 4 plus 16 over 3 minus a negative 2/3. So I get 4 plus 18 over 3, which is 6, which is 10. Okay, any questions on part B? Okay, great. For part C, for -5 less than x less than 6, on what open intervals is the graph of f both increasing and concave up? Okay, so for increasing, we only get to take where the derivative of positive. So for increasing, we only get to look at the intervals from 0 to 6. All right, and then concave up, we only want to look at time periods where the derivative of f is positive. Okay, so it looks like the derivative of f is positive from 0 to 1. All right, and then it would be positive again from 4 to 6. All right, and so we just put that together, 0 to 1 and 4 to 6. All right, and this is because g prime is greater than 0. Okay, questions? Okay, fantastic. So find the x-coordinate of each point of inflection. Okay, so so we're looking for a point where g prime is going to go from positive to negative or negative to positive. All right, so here it's 0, here it's positive, here it's 0, here it's positive, here it's 0. All right, but then I go negative to positive. So the only inflection point is at x is equal to 4. All right, and that's because g prime is going to go from negative to positive. Okay, does anyone have any questions about the 3 problems that we've covered?